I don't have anything prepared. I brought a knife that was in progress. Mostly I'm going to answer your questions if you have questions and tell you a little bit about the differences. I've already seen 2 free folder makers today. Every one of them does something different. And I do something different yet. And so that's the 4 folder makers you've seen today. All of us do something different. Look at the whole knife world. Everybody's got something different. You got to see what works for you. And the style of knife I make, I don't have to worry about a half thou. I got quite a few thou I can play with because I'm using bearings, cage bearings in particular, and gives me a lot of room for air. I don't have a surface grinder. Everything I do I've got an open face disc grinder, variable speed, but and that's basically how I flatten. So I'm just going to go through a little bit of the process. Oh, that's a different screw. What's different from what these other guys do, what I do. Basically, mine's built like everybody else's. We got a back spacer. This is pretty short when I got 2 screws. When I start building a folder, I use a lot of super glue. And so I'll take one liner and I'll get my holes where I want it on there. Tracy's actually got some better ideas for marking holes than what I use, and that accounts for most of my errors, is putting a hole in the wrong place or having it walk. But I get one liner drilled, I glue it to the other liner. Before they're completely profiled, they may be close, and then I back drill. And then if I need to repeat that, if I'm doing more than one knife, I will split those apart and put them on other parts and duplicate the holes and keep going and going. I want to end up with pairs though. I want both of the parts that were drilled last to stay together. At that point, I will, however it takes, I put 3 dots on this one. This is knife number 3. So those were drilled together and they need to stay together for the knife. Same way with the blade. The blade gets 3 marks on it. It's number 3 blade. From there, I can, as long as I can, oh, and the back spacer also needs to stay with that particular part. The way I make knives, I don't even know how much difference there is between the back spacer and the thickness between the where the blade's at and the back spacer. I try to keep it within a few thousandths, but we're talking a few thousandths, not a half a thousandths. Mainly because these bearings give you a lot of leeway. I mean, it's it just makes things
Tyler was
simpler.
saying that earlier, that a bearing setup is a lot easier than a washer
Yes.
setup in
Yep.
some ways. They work more consistently.
Yep.
Washer wants tighter tolerances for sure.
It wants tighter tolerances. The thing is, if you want a strong bulletproof knife, you really don't want to be using bearings. If you want to beat that knife to death, you probably don't want to be using bearings. There's too many things that can go wrong with this tiny little bearings. Also, you know, there's been talk of the side play. Other than the fact that these are more convenient, that's one of the reasons I got away from IKBS, because with IKBS, your bearings are actually right up against your pivot, and you've got such a small area where all that side play on that blade is riding. This spreads it out a little bit. Considerations for bearings. You have to make a pocket. He was talking about his counterbores here. I live with these. I even resharpen mine. Because
You can with those.
yeah, you got to be real careful, but I've got one that I've been using forever, and I just keep cutting it and cutting it. It's gonna be gone pretty soon. I didn't see where I got that from, right there.
So how deep are you countersinking your bearings, and in what surface are you countersinking?
Okay, I'm going about 50 thousandths.
So the bearings that you're using are about 63,000?
They're 63, they're 62.5. You're also, let me back up a little bit. That's actually the old way I was doing it. I'm now putting my main pocket in the blade. And I'm using this isn't the washers I use a hardened washer in the liner. Because as we talked about earlier, titanium is soft and gummy. And when you're running that bearing through it, it makes a little track in there, and that kind of work hardens, but it's still not hard. When you put a hardened bearing on there, or a hardened piece of metal in there, it just rolls much smoother. Plus then your bearing on your other side is running in the hardened blade, so everything just glides better. As Tyler said, it's a different feel. Hydraulic, I think, was the word he used. That describes it perfectly. So washers I use are 20 thousandths. I put 20 thousandths in the liner, 50 thousandths in the blade. But this blade, I think this is 332. I can't remember. It might be 1/8 inch. I think it's 1/8
Those
inch.
are hardened washers?
Those are hardened washers.
So what he's saying is, instead of that roll, that bearings running on the titanium, which is soft and it
Right.
cuts a groove, you put a hardened washer in there, and I used 110. I had some made 10 or 20. You know, it doesn't matter.
Yep.
You just adjust for your depth. But against the blade, no problem. But against titanium, you will absolutely wear a groove, and your blade's going to get sloppy. It's just how it is. So you countersink enough. We use the same bearings, I think. 63 thou, and then I'll countersink 50 with a 10 thou washer in there, and I'll leave 25 thou proud. That's my goal. Sometimes one side might be 23, the other side might be 25, because it's hard to get, when you're plunging and getting that down. But I'll put a washer next to the titanium, and then the hardened surface. And some blades I'll countersink in the blade, and some knives I'll countersink into the frame.
Yeah.
I don't know that there's a difference, but I'm sure there is. I don't know what it is. Also, before I used to break in bearings. So this is just a little something I turned on the lathe. I put that chuck it up in the drill press, have a bearing there, bring it down, run the drill press at high speed. With the washer, you don't need to do that. But if you are just putting it on raw tie or maybe stainless, you want to break that bearing in and give it a groove.
Actually, before heat treat, I do pretty much just that. I don't do it at high speed, I do it at low speed. But before it's heat treated, I run a little channel in there. I don't want to go too deep. You got very little ball sticking out of that cage, so you don't want the cage actually hitting any metal because you've gone in too deep. But it's kind of nice to have a little track in there. When you put the knife together, you can kind of feel it click into that track. You don't get that with the hardened washer. And also, when I used to do it in just the titanium, I would feel it click in there, so I don't have that anymore. But it's not that important with these particular knives. Actually, the whole pivot thing becomes not a big deal anymore. The pivot doesn't have to be precision when you're using these bearings. Actually, I need a little play in my pivot to make them work right. And you won't find it won't be moving or anything like that. Once it's together, that bearing is holding things tight the way they should be. I'm not talking about a lot of slop, but that pivot should slide in and out really nice, really easy. I used to use barrel laps like Tracy was talking about, but it didn't even require that. I roll a piece of sandpaper and run it in there after it's hardened. After the blade's hardened, I roll a piece of sandpaper around in there until I get the pivot to move in and out like I want to.
With the bearings and stuff like that, are those standard too, like the 3/16 on the barrel, or is there different sizes of bearings in diameter? Or
These are, most of them that I see aren't actually made for knife making. I think, maybe I can check this out. I think the inside diameter on these is sloppy. and I think it needs to be sloppy.
The ID doesn't matter.
Right.
They won't run against the
Right.
the pivot barrel. They'll.
And you can
because
see
what's
that
holding it
that's
is
just
the outside pocket in the balls.
it rattles around on there. It's pretty sloppy. It's just not.
Is there a set OD to the bearing?
No. Well, that's part of the reason for the track here that I put in the blade. That once you put it together, that holds the bearings in that place. Yeah, you want it close. You don't want it to get. But once that thing is, once it's tightened down, that bearing is staying right where it's at. If you make it to where the race is hitting this counter bore, it's going to cause problems. So you don't want so tight tolerance that it's actually touching anything. The race, you don't want touching anything except the balls.
Swim around in that pocket.
Yeah.
They just swim around. There's plenty of slop inside of them, because once you tighten it up, it's going to be held in place, and it's just going to find its groove, and that's where it's going to live.
And I shoot for about, I don't always get it, but I shoot for about 10 thousandths on each side gap between my liner and the blade. So when I'm starting out and I'm cutting 50, that's leaving me with about, 13 thousandths. And then by the time it's run in, we're getting pretty close to 10 thousandths. If you leave much more than that, you're leaving room for large debris to get into that bearing, and you're already going to have a problem. If somebody's actually putting it in their pocket, there's going to be debris getting in that bearing. The guys that came up with the IKBS system originally did it with a seal around the bearings. And I've thought about that before, but if you look at this blade here, I'm cramming a lot. There's no room with that internal stop pin. There's no room to put a seal on there. But at the same time, these go together dry, there's no lubricant in there, you should be able to blow most anything out of there that with just the computer air cans, blow the dust and debris out of there. Back when we were still had a big presence over in the Middle East, I had a guy in the Army want to buy one, and he asked how he thought it would do over there, and I told him I didn't think it would do very well. We're talking serious sand and microfine sand that gets into everything. It's just not. That's why people do them with different ways. These aren't made for sand. You don't want to play with these in sand. And the internal stop pin is a bad idea for that too. You get crap in there and it's going to get beat in and it's not going to come out. It's just everybody's got something different. This is what I did. There was something else I was going to cover on this.
How do you go about setting the internal stop pin when you're doing the blade? So when these guys do it, they open it up, they drill a hole through the thing, and then that's how it stops the blade when it goes. When you're doing an internal one like that, when it's actually milled into the blade, how do you set that in order to...
I'm glad you asked that, because I wasn't even thinking about that, but that's a good thing to cover. I put it together in a sandwich just like everybody else does. I actually put the whole knife together, not just one liner. And I put a pivot pin in and everything. And I take it to the open position and I actually super glue the blade and everything in place. I got the backspacer in place. I super glue the blade where I want it, and I back drill. I actually just start the hole. And then I break the glue and put it to the closed position and drill that stop hole. So then on my, I use a cheap Harbor Freight mini mill. I've just got a plate with a pivot screw in it, and I put the blade down on that, and I bring a dowel the same size as the hole I've drilled down into that hole, just to line up, and I lock up the mill table, and then I can put my cutter in there. First I drill. I just take and move the blade around and just drill holes in the arc, and then I come back with a carbide cutter and ream it out, just moving the blade around like this. Some people use a rotary table I just haven't found the need for it.
You can do it. Well, you can do it. You just by eye. Put a hole there, drill holes, just like you're doing a guard, right? First time you did a guard, scratch the line, drill a bunch of holes, and file it out. You can do the same thing there. Now, I tell you, the arc on a hidden pin, on these is not 180 degrees. You would think that it would be a half moon, right? Open and closed. It's not, because your blade is not centered exactly in the center. Your arc of the hidden pin in that slot is somewhere around 160 to 165 degrees. And then you got the thickness of the pin. I use a 3/32 pin. I used to use a 1/8, but boy, things get crowded between bearings and a stop, and then the slot. If your stop pin is 1/8, well, your slot is going to have to be at 130 to 140, because you're just not going to get it right. You're going to need that. You don't want it to bind. So I went down to a 3/32, holding up just fine. But I'll pass these around. You can take a look at where the slots are typically. Now, I drew this up on CAD, and I can take and touch and grab this blade and swing it around, and I can position exactly where I want everything. That's the beauty of CAD, is trial and error and walking that in. But that'll give you an idea of what the internals look like.
Oh yeah, and the other thing about placing your stop pin hole, this is a very narrow knife. And one problem I discovered early on when I started making flippers was that if you don't have enough lock below this arc, you're going to get, it's not exactly lock rock, but it sort of is, because you need your lock surface where you're actually stopping to be below this stop pin hole. Otherwise, it's the leverage is wrong on it, and you can actually make it move. And one way to not fix it, but to get away from it, you still have to be below it, but changing where your arc is. Normally, my arc's pretty much right out in the front. This one was so narrow, I had to move it up. And I've got a very small locking surface here, and just like Tyler was talking about earlier, you're just using just the very bottom of this. It's a lot easier with a wider knife, because you got all this area to play with and get well below that arc for your leverage. Oh yeah. And figuring out where to put your hole. What I normally do is I just start my counter board just to make a scratch around where it's going to go, and then I'll take whatever the diameter of my pin is, and I'll measure to the edge of the hole with calipers, and then I'll add a few thousandths plus half the diameter of the hole. I'll come out and I'll just scratch an arc there, and then I can decide where on that arc I want to start my hole. Does that make sense? Did I make sense on that? What else? Oh yeah, we covered earlier lock. I was taught lock length is 2/3 of the length of your handle. R.B. Johnson taught me that, and I don't measure anymore. I kind of eyeball. But if you look at all my, they're pretty much going to be 2/3 2/3 of the length of my handle.
How do you grind your lock face?
This lock face or that lock face?
On the blade.
On the blade. That's complicated. We've talked about that. That's why Tracy's asking me.
We talk about it a lot.
He's got a scientific method of doing it. I've got my way of doing it.
Mine is not science.
I saw a Strider knife. I used to do mine flat, and I wound up with a lot of lock stick. And I was playing with my apprentice had a Strider that he won at something, and I was looking at it. All of a sudden, I realized this was hollow ground. Actually, I think they did it with an end mill. But it got me thinking how that was kind of cool, because your lock comes in, and when your lock swings, it's actually changing length. And So with that curve in there, it comes in and it wedges in better. It kind of almost flattens up against your curve. Gives you better contact. So I came up with a way to use I got a KMG. It's just got a platen that bolts down. The platen is not adjustable, but I took my work plate. I took my platen and I tilted it to where the 2-inch wheel's out here, and I can adjust it up or down to get how much angle is on this, and I can cut my 2-inch hole in here. And now I've got scribes on my platen, so I bring it in, and I use a piece of scrap to grind until I get, I can't remember, 10 degrees is what I was using. From peak to peak, you know, that you'll have your cut here, but from peak to peak is 10 degrees. And it was nice because even before I was treating the lock face, they weren't sticking. Even with it soft, yeah, I would just use this across there.
So 2-inch diameter radius, 10
Two-
degrees on the
If you look
Yeah.
right here, this is kind of what he's talking about. This is a 2-inch wheel.
I've had such a hard time describing what this.
This is a 2-inch wheel, and the center of that wheel is about there. Okay, so I arbitrarily grabbed a 1, 2, 3 and a piece of this. I set that on there, and I showed Tyler this. He was laughing. I just get that square across there. It's just flush. Okay, so it's repeatable. This goes up and down. This is square to that. So now I have a 2-inch wheel. The apex is slightly above of the table, and I'll take my blade and I'll just push it in. Push it in there, check it. Push it in, check it. And that's all there is. It's very repeatable. It comes out to around 10 and a half degrees. And I'll check it with that little gadget there. And if I need to, I might have to go up a little bit or down a little bit, or I'll finish it with stones and walk the fit right in.
And I guess that brings up the treatment of the lock face. A lot of people use a carbudizer. I bought this carbudizer. I only paid $160 for mine.
Boy, time to change, back before electricity.
But what I found was it made my locks more sticky, and I think I didn't play with them like Tracy was talking about. Man, they were sticky. And now I can't remember who it was I called, but I called somebody and they said, cook that lock 3 times, to cherry red 3 times, let it air cool. And I've had my best luck with that. I knew that you couldn't heat treat titanium. And like Tyler explained earlier, all it is you're bringing out these carbide, titanium carbide crystals on the surface of the metal, and they're very, very hard. So you're not heat treating the block, but and you'll see when you go to clean up the sides of your liners, it really is, there's a thickness actually there, because when you start to sand them, if you're sanding with 220, it takes a little while to take off that. There's like a little bump of extra metal on there, and it won't anodize. So that's how I treat my lock faces, and the carbudizer sits there, and I don't use it anymore.
I'll give you $100 for it.
So I didn't cover a lot of stuff here, but you guys must have questions. Ask.
I guess ask any questions that you got about anything at this point. We're about done and we're ready to move into the raffle. So any questions or any comments or anything for the good of the order?
What do you guys recommend for lubricant?
Grade 1 oil, whatever the hell.
For grilling, for knives,
What's the minimum thickness that you're
for
comfortable
washers,
with leaving?
I always
Yeah,
use nano oil. It's called nano oil.
I would like
That's what I use.
100,000,
That's
Yeah.
but this is
They use nano oil.
Yes.
This is an 1/8"
Or
blade,
whatever, yeah.
and I've taken almost 50 off each side.
Yep, that's it.
It
Almost.
costs more than whiskey.
What I do,
It's like $30.
I'd like 100 in there.
This
What I
is
do when
cheap.
I'll
No,
take
this
more
is
out
like
of here.
5 years old. It'll last you forever. One little drop and you can
And
get
then
inside.
You
the
can
second
balance
and
it,
touch
because you-
One
You know,
drop.
you can bring that
Less
down
oil is
to
better than more.
40,000.
When you're
Oh,
oiling
yeah.
your first
Yeah.
filter,
That's fine.
especially
Yep.
liner
So I'm always
locks, you
trying to
put a
thin 'em
drop of oil
down.
in the little detent
And
socket
you just run out of room,
on,
you know.
on
and
Right.
oil
it's
that,
like,
that
man,
detent
'cause
ball
Yep.
first.
you got 20,000.
Yeah.
Okay,
You
get
don't
a
have to
little
worry
oil,
about it when
put
you got a
little
nice
drop in
thicker
that
blade.
detent
You can just take it
hole,
out and
okay?
get your
And
100,000s.
then, your bearings or washers, either way, and work it. And then I take air and I blow out the excess and wipe it off. I don't want a lot of oil in there because it just leaks. The day later, you pull it out of your pocket, you got oil stains all over. It looks like crap. But this nano oil is nice stuff. Having said that, I grab 3-in-1 oils. The sewing machine, it doesn't matter. I just
And-
like this because it's got this cool little applicator.
As far as oils, for me, I don't touch oils when I'm
Yeah, bearings don't need oil.
Yeah.
They slow it down and they
Right.
they track dirt, so you don't need
right, and they attract dirt for the bearings. It's mine go together completely dry. Not only that, I've had a big problem in the past. It took me a long time to overcome it. You got to put Loctite in your pivot screws, otherwise you'll be getting knives back time after time after time for loose pivots. And things go bad when pivots go loose. They start scratching the sides of the blades, and it's not good. So if you're doing everything dry, when you put those brand new pivots in, they're all degreased. There's been no oil around anywhere, and the Loctite actually holds. Blue.
Loctite, everything. Every screw on it, Loctite, because they're like a Harley. They will shake apart. Loctite, every screw on
Yep.
it. And because they will fall apart.
Yep.
And one thing I found it's worked good, and I discovered this making slip joints. Whenever you go to assemble that knife for the first time after you've heat treated your blade and your back spring, you're putting it together for the first time, and you're getting ready to see the walk and talk. Well, you got a 60 Rockwell knife, and then you're moving it on a 46 to 44 Rockwell spring. That wants to gouge real easy, especially if you don't have your corners radiused. And even if you do have your corners radiused nice, it's still going to gouge and dig. One thing I found that broke that in easy, and I've never experienced any gouging, I took cam and lifter installation lube. Cam's that thick red
You want me to cover that?
cam and lifter installation lube. It's got zinc, magnesium, all that. It's a cushion. It's for metal to metal contact, and it will break in stuff like that. And I will put just a minimal thing on the detent ball, and it will.
I got molybdenum disulfide.
Yeah. That's one thing I use that's really helped my stuff out.
Actually, I didn't even think about it. I actually do use a little bit of grease, but it's not in final assembly. It's when I'm running in the ball. I will put a little, even with the ceramic balls. The first time I run it over there, I put a little grease on that ball just to start the whole thing, and then it all gets cleaned back off. But one thing Tracy just brought up, he wanted me to show you. I put this little ramp. That's right. I watched the track, and I cut and polish in a little ramp right there so that when you're closing the knife, you don't have to keep pushing the lock over to get it up that.
Because you will at some point, if you, I forgot to cover this as well.
You'll rip
But
out that detent.
You will, with the ceramic detent ball, you can shear it in half by not having that
Oh, really?
kind of wheelchair ramp cut
Never
in that.
used
Just
Not only that-
It will shear them if you're not careful.
People
Gives
will
it a
cut
smoother
themselves.
feel. I mean, when you're closing, it just smoother.
Yeah, it gets rid of the bump.
Yep.
Yeah.
People who aren't really familiar with liner locks will cut themselves trying to close that knife if you don't have that ramp on there, because they'll start to get it closed and they don't keep pushing on the lock, and they'll sit there trying and they'll it'll finally break and they'll cut themselves.
So let's talk about putting in a detent ball. So I use a 2mm, he uses a 1/16. So you got your hole, and I use a number 49 hole in my lock bar. And so say this is my lock bar. I'll take, because you can't grab them with your fingers. I got this little thing there. I set a ball bearing right there, and this happens to be ceramic. Then I have a 15 thou washer like that, and I will take, and again, I'll just place that right over the ball bearing, there, and this is just mild steel in there. I'll bring that down, and you press like that, and you will feel that just settle right in. You'll feel it just, it would just go, and it won't make that noise, but it'll just fit right in. And you pull it, and that washer is only 15 thou, but it dents also the bottom there, and it fits. And then you just measure, you know, with your caliper, measure that, and then measure with the ball. And I shoot for 25 thou per hour. I think that's about on a bearing. Or, you know, if you're using, but you got to have that offset. You got to have that ball bearing. Detent ball has to be thicker, stick out more than your washer. Otherwise, it just jams up on a liner lock. Now, on a frame lock, it'll just overspring. But on a liner lock, it jams in there, and then you got to relieve inside of your scale. But really simple, and it just pushes in. And it's, boy, after you do a few, you're going to be within a thou every time on how proud it is.
I forgot there's one other thing you do. This is pretty much only for flippers. You don't want it on a regular liner lock. But my detent hole in the blade, let's say your ball's coming in this direction. You want this edge to always be sharp. You want that to break hard. But Tyler was talking earlier about having that blade suck in once it's pulled in, and with a flipper, I pretty much drill mine straight on instead of offsetting them. What I was told to do, and again I can't remember who taught me this, but on this back side, all the way from here, all the way around over here, you can break this edge of this hole. I use a very small carbide tool, break this edge. And what it does is it allows the ball to travel this way a little bit more and keep this edge sharp, so you've got that nice snap.
You're just relieving the backside of the hole. So
Relieving the backside of the hole,
back a little
yeah.
bit farther or deeper.
And it kind of helps suck the blade in a little bit.
I do that routinely. If I got a trouble on a detent and it's not quite right, and I'm down as far as I want to go, I'll relieve along the backside of that hole, and it will give you a sharper pop on it. For sure, a flipper. I think that's about everything. What do you think? Good enough?
Yeah.
All right, Jeff.